Okay, this is a recorded video. Can you hear me? Thank you. Now I will begin the artificial intelligence and machine learning class. Today we will follow. So, today we will follow this story. First, I will talk about how this class will be run, and then explain the class content, what artificial intelligence is, and what machine learning is. In this class, we will use Python with Google Collaboratively. I would also like to check if you can use this environment with your Google account. Okay, just a minute. As stated in the class syllabus, okay, as stated in the class syllabus, let me first explain the aim of this class. The aim of this class is to understand the history and background of artificial intelligence and to learn the fundamental theories of machine learning. This includes deepening the understanding of specific algorithms through theoretical aspects and practical application using Python. Uh, a fundamental understanding of linear algebra, calculus, and basic statistical calculations such as matrix multiplication, division, and expectation is required as prior knowledge. Experience with Python is optional, but having a basic understand beforehand is recommended to reduce the workload for preparation and review. Hmm. Uh, okay. So as you can see, this course heavily involves mathematics and Python. The the course plan is as follows. Today, in the first lecture, I will introduce what artificial intelligence and machine learning are. For the second to the 10th lecture, I will explain basic machine learning method. In the last three lectures, from the 11th to 13th, I will introduce neural networks, which are advanced machine learning method. Since this is just an introduction, if you want to learn more about neural networks, please take the deep learning class. There are textbooks and references. I'm sorry, but they are mainly in Japanese. Uh, so you don't need to buy this textbook. Uh, this is probably the most important point for all of you. Your grade will be decided by the final report, 50%, and in class report, 50%. In-class report questions given each class to check your understanding of that class. Please answer them through Google Forms. These will be given every time, so please make sure to answer them. While we do check your online attendance now, we will manage attendance through these in-class reports to make it easier. So please make sure to submit them. There will also be a final report. Report assignment will be given at the end of the semester. I will share examples of the last year's report assignments later for your reference. Your grade will be decided 50% by the final report and 50% by the in-class report. So there will be no final exam. If you miss a class, please follow up on the missed content by yourself. I will try to post class material 1 week before each class. Also, if you miss 2 or more classes in a row, please contact me by email or Teams. Uh, Especially this year, since the class is held in the first quarter, there are 2 classes in 1 day. However, if you miss 1/3 of all classes, you cannot receive credit. This is stated in the course guidelines. We have 13 classes in total, and 1/3 of 13 is 4.3333. This means that if you miss just 2 days of the classes, you are already at least thinks there are 2 classes per day. Please try not to miss any classes. Okay. So that concludes guidance. If you have any questions, please write them in Teams chat or email. Okay. Okay, so okay, now I would like to start the lecture content about artificial intelligence. We will follow this flow. Uh, first, okay. First, artificial intelligence is a field of software technology in computer science. Uh, Computer science includes basic computer theory, hardware technology, and software technology. Sorry, this is Japanese. uh, okay, so. And artificial intelligence. Artificial intelligence is one of these software technologies. Many different terms will appear in this course, but unlike in mathematics, the definition of these terms are often not clear and vary depending on the person or book. Please be aware of this. When asked what artificial intelligence, machine learning, or neural network, especially me, there is quite a bit of ambiguity. As for the overview of artificial intelligence, it is related to various fields, not just programming. It is connected to cognitive science, uh, psychology, philosophy, and others. Cognitive science is a field of that process, cognitive process and consider intelligence and intellect. Mhm. Uh, Psychology is a research field focusing on the intelligent behavior of living organisms. Philosophy is a field of that examines human intelligence and intellect. Uh, there are the various subfields within artificial intelligence. Let's introduce these in next slides. One of the subfield of intelligence is machine learning. This is what we will cover in details in this class. Machine learning is a technique that provides computer program with mechanisms to perform learning. Now, I will explain the specific methods later, but for now, please think of it as follows. Learning dataset is prepared and the system is made to extract data, trends, and filters, which are then used for classification and prediction of unknown data. Examples include linear regression, k-nearest neighbors, k-means, neural networks, and deep learning. There are many types of artificial intelligence that don't use neural networks. One of them is evolutionary algorithms. Evolutionary computation is technology inspired by biological evolution. Specifically, it applies character of the biological populations adapting to the environment over generations to information process. An example is generic genetic algorithms. Several models are created and by several methods are created and by mixing these models, new ones are produced. Then the best one among them are selected. If that's all, would just become average. So sometimes mutations are introduced to create not just average models, but slightly different ones. This method is applied to problems such as the traveling ceiling problem. The traveling series problem is where there are multiple locations and the salesman must visit multiple destinations. Each destination need to be visited only once. The question is, in what order should the destinations be visited to finish as quickly as possible? So the traveling salesman problem asks which route is the shortest to visit all destinations. For example, I'm sure you will order things on the internet. When you do, many people order online, and these items need to be distributed from warehouses. Deciding in what order to deliver these by truck corresponds exactly to this problem. The traveling salesman problem, which is necessary in various situations, is known to have the computation time explode as the number of destinations increase. Generic algorithms are used as one solution to such difficult problem. It is also said to be used in optimizing the shape of the Shinkansen bullet train. Another method is swarm intelligence. This is a technique inspired by intelligence behavior exhibited by schools of fish or flocks of birds. One example is particle swarm optimization. Let's think about finding the most depressed part of field. If the field is very vast, it is difficult for one person to find the most depressed part. The lowest point is height. So we search with many observers. Many observers are pressed to measure the height, and they also explore a bit around them. Let's call the best spot found by the entire group A and the best spot found by each individual observer BI. Observer I is moved considering the position of A and BI, and there they measure the height again and explore the surrounding, gradually accumulating information. By repeating this, most particles move toward good spots, which is how particle swarm optimization works. Although quite different in nature, natural language processing is also a technology included artificial intelligence. It is a technique for machines to handle language used by humans, and its technical range varies widely depending on the purpose. Example including document little automatic proofreading, automatic summarization, automatic document generation, machine translation, and so on. When this technology first appear, what is next? Okay. Uh, when this technology first appeared, there weren't many practical applications, but recently there has been rapid progress. You may have heard of names like ChatGPT, Claude, Gemini, Grok, Notebook LM, which are various AI models with chat-style interface. ChatGPT was released by OpenAI 2022. So very recently. It can generate text, generate code, translate text, summarize text, correct text, fix and port code, analyze data, and do various other things. Recently, it can also perform web searches. These methods are receiving a lot of attention lately, but I think you won't have many opportunities to learn about them in class. So let's delve a bit deeper. They are a type of large language model, so LLM. This simple idea is to predict the most probably word that follows a given word and connect them. For example, if we have the phrase once upon a time, what would likely follow is there was. So once upon a time, there was blah blah blah. By repeatedly predicting what comes next. A natural text is generated, which is the idea behind the large language models. This allows for generation of very natural text and enables various things like the text generation and code generation mentioned earlier. Okay, so let's try to use ChatGPT. This is a ChatGPT screen. So this is chatgpt.com. When I write a question, so like this, for example, what is efficient Yes. So it generates an answer like this. This is not a document I prepared in advance. There is no person somewhere creating this for me. The AI, artificial intelligence, understands the content and generates the most appropriate text. The key point is that the performance of this technology is extremely good. So this technology is currently being used in many different places. You might use it at least once yourself. Okay, let's return. Yeah, okay. Okay, so however, even though it may seem to be saying reasonable things, it can sometimes say completely incorrect things. This is also called hallucinations. When using it, one thing to be careful about is that the copyright of generated content belongs to the creator. This means that if I write the text that was just generated somewhere, the copyright belongs to me. So if incorrect content is generated and I copy and pasted it becomes my responsibility. Also, if there is copyright infringement, so the creator is the one who take responsibility. So saying ChatGPT say it so, so ChatGPT wrote it, so I couldn't help it. Is not an excuse. Also, at the Tokyo University of Marine Science and Technology, submitting reports or papers created using generative AI, so ChatGPT, Claude, Gemini, Grok, and so on. Mm. Is generally not allowed. This means that using AI for reports is basically prohibited. However, using it as a supplementary tool for gathering correct information is considered okay. Uh, mm, So it might seem complicated, but the basic principle is what is wrong for human to do is also wrong for AI. For example, copyright infringement using somewhere else's text without showing the source is wrong, or copying a report made by a friend is wrong. In the same way, copying a report made by AI is also wrong. So far, I've been talking about the negative aspects, but it is very useful when used as a supplementary tool. It's extremely efficient. I use it myself. It's incredibly useful for things like converting bullet point into natural text or proofreading text, making a text better, finding alternative expression when the current one doesn't feel right. And above all, it never complains no matter how many questions you ask. since it generally says correct things about common knowledge. When you wonder what is this all about and ask a person, sometimes you might not understand their explanation. It's acceptable to ask a few times, but as the number of times increases, you start to feel a bit sorry. However, with AI like ChatGPT or Claude, there's no such worry, and you can ask questions as many times as you want. And that's how convenient it is. So, I think it's good to know what it's like at least once. It's certain that tools like ChatGPT won't disappear in the future. Historically, when ChatGPT first came out, I thought it might be dominated by OpenAI, but now there are free models such as DeepSeek. There are even free models with open source code. So the situation where one company dominates seems to be disappearing, and this technology is unlikely to disappear. That means we have to learn how to work with it properly. So you might think it's convenient when writing reports, but as I said before, simply copying is not allowed. However, those who are lazy might generate content and copy it as is. Not only does this is not contributed to your growth, but when you enter the workplace in the future, the question becomes, can you do something greater than ChatGPT? To avoid being replaced by ChatGPT and similar tools, you need to think about what you should want to at this university. When you use ChatGPT, you might think it can be everything, but it's surprisingly not that versatile. For instance, it might hallucinate about very niche content. Also, it cannot generate the most up-to-date information because it's not included in the model. Also, we humans have bodies. ChatGPT and similar tools don't have bodies. Therefore, being able to actually move becomes our advantage. In work, there will always be interaction with people. In such cases, knowing technical terms helps communication flow smoothly. For example, when saying linear regression might work well for this, you don't need to explain what the linear regression is each time, of course. Of course, you can look up expressions, but knowing common term makes communication easier. Uh, each of you probably has something you are good at. It's hard to explain your specialty without knowing the technical terms. I think one aspect of university learning is to be able to do this naturally. So I believe it's important to properly understand the terminology and knowledge in this artificial intelligence and machine learning class. Whew, I got a bit sidetracked, so let's return to our discussion about artificial intelligence. Hmm. Okay, next Next, I will explain image recognition. Image recognition is technology that mimics uh, the role of the human visual system. It has functions such as determining and understanding what an image represents. At first glance, you might think it's just what I see, but images contain various information such as whether it's a cat, bus, tomato, a rabbit, making the system focus only on the desired information is actually difficult. Recent model like ChatGPT can do this easily when you input an image, but historically it has been a challenging task. For example, okay, for example, when showing a photo of a dog sleeping on a road, it's not easy to determine whether the road or the dog is the main subject. There are such difficulties. Okay. Now let me introduce how artificial intelligence is being used. I mentioned ChatGPT earlier, but there are many other examples. For instance, voice input through natural language, like Apple's Siri, has made it possible to search for information using keywords and operate smartphones. This involves speech recognition and speech uh, synthesis technologies. Uh, search engines, search engines by Google and Yahoo can also be considering applications of AI. They have crawlers that collect data from the web servers. But during a search, finding what the searcher truly needs among vast amount of data is a very difficult task. AI technology is used in these search engines. The translation function in a web browser is another example. So on a Chrome screen, you can translate foreign language web page with the translate to Japanese option. So like that, for example, this is English. So we can translate it to Japanese like that. So this is an example of machine translation technology. Also, when looking at the products on next page, when looking at products on shopping sites like Rakuten or Amazon, you might see recommendations like, how about these products? Such recommended displays are modeled using machine learning technologies based on customer information like search history and other history. Facial recognition technology is a familiar example too. Uh, Recent smartphones can so authenticate device just by showing your face without entering a password. This use image recognition technology. Autonomous driving technology is also evolving. It has been a topic at the Expo event at Osaka. recently, so in Japan it's banpaku. And several car manufacturers have implemented featuring like following the car in front, albeit with limitations. Machines are driving by making judgments based on the information from radar, GPS, and camera images. Image recognition and other technology are used in background. AI players in games are also well known. Methods are used for games like Go, chess, and shogi, traditionally learning from a large amount of match data was used, but recently it has become known that they can become strong even without using human match data. Deep learning is often used in such game AI. In the financial field, there are automated trading systems for stocks and securities. At the present, the manual portions performed by humans in financial transactions are steadily decreasing. AI is used for sales forecasting and inventory management. By having the system learn from large-scale sales data and infer future sales trends, it can make a decision to increase inventory for products likely to sell well and decrease inventory for products that aren't selling much. Finally, there is robot motion control. Reinforcement learning, which autonomously acquires complex motion like bipedal walking, is used. As in recent years, quite acrobatic movement have become possible. For example, robots like this have been developed. Okay, let's check. This is one of the famous robot, Atlas. Okay, that. So as you can see, this robot can stand up and walk naturally. It can even do backflips and has become capable of quite advanced movements. So, oh, this is image. This is real. So this is recent technology. So it also performs practical tasks like carrying objects. This uses technology called reinforcement learning, which I explained earlier. Okay, let's back. Now let's return to the question of what artificial intelligence is. When it comes to artificial intelligence, there is a classification of weak AI and strong AI. Here. Weak AI is technology that uh, observes intelligent behavior exhibited by living organisms or humans and utilize result in software creation. On the other hand, strong AI is technology aimed at artificially creating the intelligence and intellect possessed by living organisms or humans. In other words, weak AI uses the intelligence behavior of organisms and humans for software creation, whereas the motivation behind strong AI is to artificially create the organisms and humans themselves. In the past, weak AI was mainstream, but with the emergence of ChatGPT and similar technologies, the realization of strong AI has become more realistic. So now 40 minutes. So let's take a break a little, maybe 5 or 10 minutes. So, if you have any question, just me, just me, so please break time. よいしょ。うん。 Okay, let's restart. Okay. The recent popularity of AI has been influenced by three technological advancements. First is a dramatic progress in computer hardware technology. Second is spread of the internet. And third is the development of artificial intelligence technologies itself. Now let's look at the history of AI. So computer science began in the 1940. First, ABC suggested the electronic automatic computing device could be constructed. Then ENIAC made it possible to calculate artillery trajectories like that. So von Neumann was a person who had a major influence on computer development. He made significant contributions to computer development, such as publishing a technical report related to EDIAC. Von Neumann also proposed the concept of cell automata. This is a simplified mathematical model of phenomena where individual elements interact over time, and it has become fundam foundational knowledge for thinking about modern computers. Alan Turing is another important figure. He was a mathematician, famous for contributing to the uh, decryption of German military ciphers in World War II. This story was made into the 2014 film, The Imitation Game. If you are interested, it would be good to watch it. One of the things Turing sort of uh, besides computers was a Turing test. This is an experimental procedure related to the definition of intelligence and intellect proposed by Turing. Simply put, it's a test to determine whether you are talking to a human or an AI. This test has become even more important now with the development of AI. I want you to remember that these basic ideas about AI have existed since the 1940s, quite for a long time ago. Okay. The field of artificial intelligence was established in 1956. The term artificial intelligence is said to have been defined for the first time at the Dartmouth conference. The claim at this conference was that learning and other characteristic of intelligence can be described in a form that can be simulated by computers. In other words, the claim was artificial intelligence could be realized through programming. In the 1960s, natural language processing systems were developed after another. For example, ELIZA was a natural languages processing program that simulated the behavior of the psychological con counselor, responding using syntactic analysis and pattern matching. This is led to the first AI boom from the late 1950s to 1960s. In this boom, inference and search become possible, but systems like the one that allowed manipulation of blocks through English dialogue only worked for predetermined shapes. Dealing with real-world problems involving various intertwined uh, factors was still impossible. In the 17th, in 1970s, expert system emerged. MICIN was a medical diagnosis support system in patient conditions and test results then inferred using a prepared knowledge base. DE and Dendral. Similar in framework to medicine was MICIN, was a system that supported mass spectrometry in the field of chemistry. For these specialized matters, information was well organized, so it was proposed to extract relevant information from a knowledge base using inference engine and combined. So this led to the second AI boom in the 1980s. When given proper knowledge, computer become capable of inference. However, the problems during this period were that enormous amount of knowledge had to be prepared, and it was extremely difficult to convert that into description understandable by computers. Ambiguous expressions or feeling like somehow couldn't be expressed. Okay. Separately, although it wasn't in the spotlight yet, an artificial neural network called the perceptron was developed in the 1960s. An artificial neuron is computational structure that models the network circuits formed by biological neurons. It calculates the product of input signal with weights and then applies an activation function to this product to derive the output. But the perceptron is type-layered neural network here. Uh, In the research done by Rosenblatt and others in 1958, the connection from the input layer and the hidden layer was randomly determined. Backpropagation is an algorithm that uses the error between the output value and the expected value, which is generally called teacher data, to adjust the parameter within the network. It was published in 1986. Initially, it didn't receive much attention because people didn't understand why such a strange approach was being used, but the situation changed around 2010. In the 2010s, convolution neural networks emerged. They are neural networks inspired by biological visual uh, nervous systems. From around 2020, in image processing, they developed the technology that applies small size image filter in convolutional layers to emphasize feature within images. With this technology, it became possible to identify image with higher accuracy than humans. This marked the beginning of the deep learning era. Additionally, the use of big data through IoT, which stands for Internet of Things, also progressed. The spread of the internet made it possible to area collect vast areas of information. For example, as you all have smartphones, these phones are constantly collecting location information. So there is already enormous data just from one person's location information. And since Japan's population is about 100 million. If we had data from all these people, it would amount to 100 million people times to 24 hours of data. In the past, it wasn't possible to collect such data, and even if it could be collected, it couldn't be analyzed. However, with improvement in computer performance, it became possible to collect and utilize this data. Since neural network methods require a large amount of data by combining with big data from IoT, deep learning began to function very effectively. Now, this is what's called the third AI boom, which continues to this day. ChatGPT, which I mentioned at the beginning, can also be considered part of this boom. As I mentioned earlier about game AI, game playing programs have actually existed for quite a long time. First, there was a checkers program. Checker is a board game where pieces are captured. Now, programs were developed for this game. The checkers program utilizes knowledge representation technology for displaying game information in a machine-readable format and search algorithms for finding data and match conditions. As time progressed in 1997, a chess-specific computer called Deep Blue was developed. Deep Blue was a chess-specific computer with parallel computing and additional chess-specific search hardware. This computer became famous when it defeated Mr. Kasparov, the Russian world champion at that time. And in recent years, there game called Go. Go is a game where stones are placed on a 19 times 19 board, but the board is too large. But the board is too large. So there is 381 patterns. Maybe? After placing one stone, where to place the next move must be chosen from 19 times 19 minus 1 positions. Having to try all possibility made it extremely difficult. However, in 2016, a program called AlphaGo appeared, and it was extremely strong. AlphaGo was a program that utilized machine learning and deep learning technology, uh, pushing training methods for the board evaluation system with traditional search techniques. AlphaGo played against Lee Isedo, a professional Go player from Korea. This was when I was a student, and I watched it in real time. The AlphaGo teams says they would play 5 games in total. Normally, if you win 3 games, you win the match. So it would be end there. But regardless, they said they would play 5 games. At that time, people thought that since Go is difficult, human would win all 5 games. The match was best of 5 series, and AlphaGo won the first game. Isidro seems to think I was a bit careless at that time, but then he lost the second game too. Things started to change, and the press conference after the second game was almost like a funeral. In the third game, Isidro lost again. Seemed like humans might end up losing all 5 games. But in the fourth game, Isidro an expected move, and from there, AlphaGo started making incompatible self-destructive moves, allowing the human to win. So it becomes 3 win to 1 loss, and in the final game, AlphaGo won again, resulting in a final score of 4 wins to 1 loss for the machine. This became a huge topic as a dramatic story. Instead of who was still young at that time, retired afterward. This is the historical background. It's a fairly recent story. For machine learning, discussion like these, they are written in programming language. Python is commonly used for such language. Python itself is a procedural language developed in 1991. It has existed for a long time, but around 2010, when the AI boom I mentioned earlier arrived, open source libraries such as Scikit-learn, TensorFlow, CNN, PyTorch, Caffe, Chainer, and so on began to expand. Uh, Open source refers to source code that allow free use and distribution, while a library is a collection of code. If you can prepare data according to templates using these libraries, make it possible for anyone to easily implement and learn machine learning. Also, since they are free, many research began using them, leading to a wide range of code from basic to cutting edge being made publicly available. With a background, especially in the field of deep learning, Python est established its position as a standard platform. That concludes our discussion about artificial intelligence. If you have any question, please ask. Uh, since we have been going for a while, let's take a break now. Okay, now let's continue. Next, I will talk about what machine learning is. We will follow this flow. This flow? To briefly explain machine learning, it is a technique for generating models for a given this one. So to briefly explain machine learning, it is a technique for generating models from given information and adapting a computer program to the environment. But since this expression alone might leave you wondering what it means, let's move on to more specific topics. Uh, Regarding the learning part of machine learning, there are two types of learning. One is deductive learning, and the other is inductive learning. Deductive learning is learning that take you from abstract concept to specific knowledge, while inductive learning is learning that creates model from specific knowledge. In machine learning, inductive learning is fundamental. It learns specific pattern from data such as table data, image, and audio. Let's think about this with concrete image. Example. As an example, inferring from data, if you apply force to a spring to stretch it, you can see the correspondence between how much force you apply and how much it stretches. When you plot this on a graph, it seems to be proportional. So we understand that this relationship can be expressed by Hooke's law. This is inductive learning, which corresponds experimental science. Uh, on the other hand, building up theory is like considering what trajectory to through object follows using Newton's equation of motion. This equation can be written as this. And solving it shows that xy trace a parabola with respect to time. This is a theoretical science. They are mixed. So if you do this on PC, it becomes computational science. And if you do the data inference part on PC, it becomes data science. In machine learning, inductive learning, which I mentioned earlier, is fundamental. Machine learning has become one of the recent research topics, and lately, it's also positioned as a science that connects theoretical science and data science. Pre- Previously, we classified it into four categories, but since theoretical science and data science cannot be completely separated, there are situations where they are mixed together, and recent research fields have come to be considered. There are two guidelines for considering machine learning models. One is Occam's model, which states that if two theories do the same thing, adopt the simpler one. In the context of machine learning, if prediction accuracy is the same, adapt the one with a simpler knowledge representation. For example, a model with 10 parameters is better than a model with 100 parameters. If there are too many parameters, it becomes difficult to understand how each variable is influencing that outcome. So, having fewer parameters make explanation and interpretation easier. The other is no freelance theorem. It states that in principle, there is no running method that always exhibits high performance for any running target. This means that for problem A, you use method A prime. For problem B, use the problem B prime. There is no universal method that works well for all problems. Combining these two principles, a simple method suited to the target is desirable. So in machine learning, there are various methods depending on the situation and the problem. So you need to change the method, which is why it's necessary to know various methods. Like that. Also, there are various type of machine learning. One is supervised learning. This is a format where the model runs using correct data. It infers unknown data based on the knowledge learned from the correct data. For example, you teach the model by pairing dog photo with word dog. In this case, the label is dog. Uh, when given photo data like this, the model is asked to predict this label. There are also cases where such labels are not set. This is like that. This is called supervised learning. Examples include cluster analysis and principal component analysis. In this case, we will also cover clustering for instance, asking the system to effectively classify many animal photos. Of course, since there are no labels, the results may not always match the expected answer. These are also reinforcement. So this one, there also, reinforcement learning, which is different from the both supervised and supervised learning. In this format, the appropriateness of individual action is not provided, but the result of a series of action is given as teach data. The evaluation value for a series of action is called a reward. Acquiring behavior knowledge for bipedal walking robots and AI players for a game like Go, Shogi, and chess use reinforcement learning. Besides the three types I mentioned earlier, there is also semi-supervised learning. There is a format that involving a cycle of training the model with a small amount of correct data, inferring unknown data and treating the resulting labeled data as teach data. A specific example of this is generative adversarial networks. For example, let's say we want to create a machine learning model that determine where the Mona Lisa painting is genuine. For this purpose, we create a machine learning model V that tries to trick machine learning model A into mistakenly identify a fake painting as genuine. Even though it's a fake, we create model A and B alternatively. Specifically, first, we create a machine learning model A1 that distinguishes between real and fake. Then we create machine learning model B1 that try to trick model A1. Now, since model A1 gets tricked, we create a model A2 that can distinguish between real image and the fake created by model B1. Next, we create model B2 that tries to trick model A2. We repeat this process. This way, we gradually obtain a machine learning model that is stronger against the fakes, which is a concept of generative adversary networks. The byproduct, we also obtain a machine learning model that can create very good fakes. Let me introduce some terms about learning method, how to measure their effectiveness. The data set used to train the model is called training data. It's the data used to determine the internal parameter of the model. This will come up many times in future classes. And I think you will understand it better as we use it concretely. Another term is test data. This is a dataset used to test the accuracy of the training model. For example, when consider time series data modeling, we use data from 0 to t, small t, for modeling, and then use data from time small t to capital T to check the quality of the model we created. Then we use the created model to predict the data after time, capital time, t. In this setting, we need to pay careful attention when talking about how good the model is at predicting data from time small t to capital T. We must not mix it with training data. In simpler terms, using an example familiar to you, training data correspond to studying in class, while the test data correspond to mock exam. If mock exam data is mixed with class material, it becomes merely memorization. So training data and test data must always be separated. And this is why such caution is necessary. Regarding how to use training data, one approach is batch learning. This is learning all at once using the entire training dataset. In the real world, for example, with weather data, the information might be obtained gradually. Using this gradually obtained information sequentially as training data is online learning. Also, since sequential update can be challenging in terms of communication, there is mini batch learning. This is a method that divides a dataset into small batches and runs from them. Regarding test data, it needs to be in the same format as training data. For example, if your model was designed to distinguish between dogs and cats from images, the pixel count of the images must match. Otherwise, if suddenly given a high resolution image, the model would say, I don't know that data format. Or if given bird data with bad data when it was trained on dogs and cats, it will say, I don't know that. So in this sense, it needs to be in the same format. However, as I mentioned earlier, it needs to be different data from training dataset. So after collecting data, you need to divide it into training and test sets. One example is k-fold cross-validation. This is mentioned that divide data into k groups and uses k-1 group for training, and that remain one group for testing. After learning and testing, you select a different k-1 group for training and use the remain one group for testing, and repeat this k times. This way, you can perform k rounds of learning. And one approach is to adapt to the average of these k repetition on the learning result. We will cover this is in more detail later. Sorry, sure. There are also other concepts like generalization and overfitting. There is an idea that trained models should be effective even for unknown data. This makes sense intuitively. In real-world problems, we don't encounter situations that exactly match our training data. We want the model to work well even with the somewhat unfamiliar data. The ability to acquire knowledge that is not expressly present in the training dataset is called generalization. On the other hand, learning that depend too much on the used data training dataset can lead to decreased generalization performance. This is called overfitting. Regularization and other techniques are used to suppose overfitting. For example, if there are outlier data points and the overall data flows align, but some points don't align that line, then if we try to adapt to the training data which includes these outlier, the model might not approximate well around these points, even though the data should be on this straight line. As a result, it doesn't work well with unknown data. Using our example, it's like we study and memorize too much unnecessary information. For instance, remembering which pages of textbook contained certain information. If the page order change, our understanding might not work well. That's overfitting. With all these various machine learning methods, there are also approaches that combine them. This is called ensemble learning. Specifically, random forest is one example of such a method. Uh, in this class, okay, so in this class, we will use Google Cloudberry as our environment for Python. Google Cloudberry is a service that lets you use a Python interface called Jupyter from your browser, such as Google Chrome, Microsoft Edge, without setting up any environment. You only need an internet connection and Google account. Normally, when you want to run Python, you need to create an environment on your computer, execute Python. This environment setup can be troublesome. However, with Google Collaborate, you can run Python in your browser without such a hassle. In today's class, let's use this explanation link. This one. Sorry. This one. Please try various things at the link if you can reach such a page. Okay. This one. Ah. So Google Collaboratory will be used as environment by using Python in this class. All the Python knowledge needed for this class is summarized in this notebook. So this Google Web Collaboratory. Also, it's quite long, like that. You don't need to remember everything. The purpose is to use it as a reference when you need help. To use Google Collaboratory, you need a Google account. So please use either your personal Google account or your university account. First, let's talk about how to actually use Python program. This notebook has two types of cell. This one. So this is text cell. And this is code cell. Code cell have something like a play button on the left side. When you click this play button, connecting might appear on the right side. This is because the program is not running on your PC. on my PC, but on a server somewhere on the internet, a procedure is need to connect to that server. So the first execution might take some time. Okay, it's working. If the top right part showing syncing, it means processing is ongoing, and when it shows a check mark, it indicates the connection is complete. Execution is complete, the content written in the parent function will be displayed. Also, while the notebook in the cloud, you can download it to your PC from File menu by selecting Download. So this is file type. In Python, you can do basic calculation like addition. So addition or subtraction, multiplication, and division. Yes. For example, if you write print 1 plus 2 and run it, 3 will be displayed. Similarly, print 3 minus 4, output minus 1, print 5, multiply 5 asterisk, 6 outputs 30. For multiplication, we use asterisk. So print 7 over 2, output 3.5. So for explanation, we use 2 asterisks. So for example, 3 squared is written as print 3 asterisk 2 and output to 9. Let's stop here for now. This concludes our first lecture. I'll now explain about the in-class report mentioned in the last slide. Here. The reports are basically designed to be completed within class time, but it's not a problem if you can't finish during today's class. The Google form is set to be editable, so you can do as much as you can today and continue later if you wish. The submission deadline is Thursday, April 17th at 13 o'clock. As I mentioned at the beginning, while I can see your access to check if you are attending, attendance will be managed through the in-class reports, so please make sure to submit them. Since they can be edited later, please make at least one submission for now. By the way, the QR code on the slide links to the in-class report, and it was created using AI. If you have any question, please feel free to ask. Okay.